UML, Unified Modeling Language. Use cases, what are they? Whatever discussion we will have, there will be an ellipse or diagram. Whatever we write here, this is use case. Why do we need use case? The first thing is, you are a developer, a programmer, or a software solution giver. There is another person or company who is going to give you this job. Now they have some requirement. The consumers have some requirement. And as a producer, as a developer, you have to understand it. How do you understand it? This is a requirement engineering process, requirement engineering activities. So this whole scenario of requirement engineering, we require the use case. That is what the system is going to do. What the system is going to do, what it is supposed to do. It is, this comes at a very beginning place, so only functional requirement is there. Non-functional requirement are not presented in use cases. So what are the sequence, what are the steps, and what are the result, and this ellipse, or we will call as a use case, what is the output and what is the observable output. If you put a card in the ATM machine, you need to get money. That is the observable result. If you are an actor, you want to get money, whatever use case is there, what do you need? You want money, or you want to understand that why the money is not coming. And there are various programs which are actually components of different other components. So what are the external interfaces which are outside the system we are not talking about, whom our system is going to interact? That is, you and me in this example are external, but we are interacting with it. And it is made for us, for human being. Why we want to automate things? Why software we are making? To automate for human actions. So how this human action are going to be coordinated? Let me tell you again that you are a developer and I or you are the people who wants it to be developed. So use case, user. Right hand side is a user and left hand side is a producer who is going to make the software. So who is going to make? And the person who wants it to be made, he need to understand it. First of all, this person who is going to be making the software, he also needs to understand. And they need to understand on the same level. Okay? The user, possibly he might not be from computer science background. He might not be technical. He just want his work to be done. So how he is going to understand? So a kid understands well with a picture. So use case is kind of a picture, a diagram. So when you show it, then he understands, oh, it will be like this. Now, whatever in the requirement process, what user want, you understood it like that only. That means he wanted a butterfly, you gave him a fly. That should not be a case. So you both need to understand the same thing. Whatever he tells, you understand. You understand with his viewpoint. It's not your viewpoint. The user perspective has to be understood. So user need to understand what he's trying to tell. Okay, yes, I wanted to tell this thing. And then you also say that, okay, you wanted me to make this. Is it okay? If he understands this, user case is the solution. Okay. So use case is very important as far as the understanding part is concerned for both the parties. Design, implementation, analysis, testing process. This use case is a very critical tool. All the software development life cycle, we have design, implementation, analysis, and testing process. This becomes very important. One more thing, user documentation. See, the person who is making, he may not be in the company anymore. And a user might have left the company, or say he might have sold a company. How these new people will understand? They need to have document, a user document, and that will only come from the use cases. There are strengths and weaknesses of this use case. There are some strength, some weaknesses also. The strength is that it is kind of a camera. It captures different actor views of the system. Then total requirement is presented in a very understandable way, and it is comprehensible, understandable by the layman, like the naive users, the users who are not technical. There are weaknesses. As I said, it only caters functional requirement, not the non-functional requirement. User case says what to do. It will tell you that, okay, this is all going to be. But what the system shall not do, should not do, is not presented in the use cases. Now, use case, these are basically diagrams. Just understand, a requirement is presented in terms of diagram for the, or you can say, the preliminary design. So here is the actor. Actor who is going to act, or who is going to initiate, or who is going to provide some support, who is going to get the result. So actor is external to the system. Always understand, actor is going to be external, interacting with the system. And if you see the stick picture, you'll see he has to be a human. No, he can be a human, he can be a man, but he can be, or this actor can be another system, like the database, like some layer in the network stack, like anything else which a system is interacting with, right? So actor, who is going to interact with the system, we represented by a stick figure in human form. Now the main thing, the crux of the story is the use case. All we are discussing is about the use case. This is in the ellipse, and this is the round shape we are talking about. This is the use case. All others are supporting cast. This is the hero of this movie. This is the male protagonist, you can say. Okay. So there will be some interactions also. There will be certain relationship among all these use cases and the actors, etc. So we will represent them by different shades of line. 3 types of main lines will be there: generalization, extend, and include. Along with this, we have the boundary. What is the system? Put it inside the boundary. What is external to the system? These are the use cases. They might be interacting in generalized way, extending, including all this is going on inside the system. But when we are talking about the external actor, external to the system, these are the actors. A human can interact, another system can interact. So these are the external interface. So you have to differentiate properly between the external people, external components, and the internal of the system. This is why you need to have a system boundary. System boundary. You will put a name also here. Now the question should come in your mind that how do we find the actors? Who will be the actors? Actor, the stick figure is like a human being. You are making a human kind of a stick figure. So how to find an actor? I'll give you some ideas. Whenever you are trying to find out the actors, you need to keep, or you need to ask some questions from here. If there is a movie, there is a picture being made, how do you choose a hero of the movie? Hero. Who will use the main functionality of the system? That will be the actor. Who will need support from the system to do their daily task? The supporting maintenance cast can be an actor. He can be a human. He can be some automated system component. Okay. As I said, who will need to maintain and administer the system? So a maintainer can be an actor, and administrator can be actor. If you understand an ATM system, you go as an actor, you try to pick up the cash. But there will be another actor who is going to put the money here, try to see that ATM is working fine or not, maintain it, administer it. He or it is going to be an actor. Also, the hardware devices. hardware devices this system is going to handle, or that hardware system is going to handle the system. Those will be an actor. The system interaction, this whole system which we are making may be interacting with some other system, that can be an actor. So there will be another system that can be an actor. This will be an actor. And also, what are these system results and who are interested in this result? Those who are interested in the result are going to be actors. You will write or you will put them as stick figures as an actor. So all these questions you need to keep in your mind, then only you are going to make the actors. Who are going to be the actors? Now the actors are being made. How do we start the work? We have the actors, identified the actors. So let me tell you how we are going to make it. Here is an actor. There is a college, there is a university or a school. What are the main actors? Students. Without students, what is the fun of having a college? So students, if there is a building, what do you do when you don't have these students? So students are the main actors for a college, for a school. So you identified an actor. Now when the students are coming, what will they do? Say for an engineering college or some degree college, they will come and sit in the canteen and they will go? No, they will come and first thing they are going to do is to register for a course. They can go for engineering, they can go for medical, they can go for pharma. So they have to register a course, and this registering of course will be your use case. And there will be a simple line, no arrow, no dash, no arrow. Don't confuse with the job titles. If your user is saying, I want administrator, I want a guard, I want some names he gives, and you say, oh, these may be the actors. No, actors and use cases are not made like this. Use case diagram shouldn't be complex. Make it as simple as you can. You need to understand, the user should also understand. If a person who is just passed out of the college, he need to understand, he need to view it and make very generic case, very basic case. Don't put complexity at first. If you go to the general store, what do you get? You get everything. Very simple, not specialized. And try not to be detailed, because we are going to do it in the detailed design and the preliminary design anyways. So make it very simple. One more thing is there. Now, there will be other works also this student is going to do. He has to go to a finance section and pay fees. Okay, this may be another use case. Now he has to sign up for certain tutorials, and you can add that. So there may be plenty of use cases depending upon the job you are doing, depending upon the software you are making. Now the other question is, how do you find use cases? This also is a question. So you need to have certain thing in your mind. Which functions does the actor require from the function? You have made an actor. Now what functions this actor want that system to do? What does the actor need to do? So this functions, these activities are the use cases. As I said, use register for the courses as one of the use case. I said, say pay fees or sign up for tutorials. This can be another use case. Apart from this, does the actor need to read, create, destroy, modify, or store some kind of information in the system? Yes. There can be another actor, say a teacher or an administrator or any other guy, who is going to make this timetable or modify the timetable. So wherever their roles are. So let me tell you, one use case is ready now. We need to have a timetable. For that, we need to modify the timetable, because without timetable, how the student is going to come at the class? You need to know what is the time of this class, humanity class or a commerce class. So the amendment or modification of timetable, the teacher cannot do by himself or herself. They need to ask they need to have the input of the student also. So now we have a use case where both the parties, both the actors are interacting. So can the actor's daily work be simplified or made more efficient by adding new functions to the system? If it is there, add another use case. Add another use case. Why we added student for modifying the timetable? Because if they both make it, there will not be any conflict with other teachers, with other classes. These are the questions you need to keep in mind in order to find the use cases now. Coming to generalization. Now this generalization, the word has come from generic or general. Whenever you go to a Walmart and you want to buy the vegetable, you'll go to vegetable section, not to all Walmart. You want some electronic device, you only go to the electronic section. Okay. So these students are quite wide, but we need to have specificity also. Students are quite general, so we need some more generalization. Okay. There is a student, now he has completed his schooling. Now he wants to go to the college, so he may be enroll in the undergraduate student. Now the undergraduate students, they want to enroll in master students, and there may be some visiting students. A student is a very, very big set. In this set, we can have multiple subsets. So this is the generalization. That is undergraduate, they are also students. Masters, they are also students. Visiting, they are also students. So we have different actors that can be generalized with some student which is more general, and we made them somewhat specific. And how do we make the diagram? We take the arrow from the lower, that is, you can say it, the student is a base, and these are the descendants, and undergrads, masters, visitors. So the arrow should start from these descendants to the ancestor, and it should have a triangular mark like this. Let me give you one more example. A bill payment has to be done. Now the bill payment can be done through UPI, it can be done through cash, it can be done through credit card, or you want to do it using the direct bank transfer. So this bill payment is a wide set. You need to have some specific or subsets also. So payment is the generalization of payment by credit cards, payment by cash, payment by UPI, and payment by direct bank transfer. This is generalization. The arrow has to be from the lower to upper with a triangle. Coming to include a relationship. Include means it is embedded. If one thing has to be done, the other has to be done, mandatory. If you're making a food, you need to put some salt. Without salt, you won't be able to eat it. I'll give you an example. You are going for a shopping online. Now you view the item. Then what do? You liked it. Now you want to buy it. Then when you buy it, you have butterflies. You want to track it. Where have the item reached? So for viewing item, you don't need to log in. Even if you want to see, no login required. But when you are going to order, you need to go to login. Without login, it is not possible to order the item. You go to Flipkart, Amazon, or any Alibaba, you have to log in. And then you want to track. Without login, you cannot track the product. So in order to do these second two activities, it's mandatory. That is, this login is included with these two use cases. It is included with these use cases. So you will make a dotted line from the order, from the track to the login, and make an arrow. This is the line showing include relationship. You will take two angle brackets and put this include here. Include here. That is, you cannot avoid login if you want to order or track. That is the main thing you have to keep in mind. Include. Coming to extend a relationship. Extend means what? If some trigger is there, if something happens, then only that use case will be called. Otherwise not. It is not included. I'll give an example. What will happen? A customer wants to do a payment. Let me tell you one more thing. If you are making some use cases have a relationship, now you can also give some note, some description about this relationship. So you can have a box, a page box with a flip, and you can write it here. This is the extension point or condition you can give. This is also possible. So we're talking about a customer. Now he wants to make a payment. When he wants to make a payment, if the extension point is payment type, it is extending the make payment. So if it is one kind of payment type, so if the user chooses credit card, payment by cash will never be executed. It will only payment by credit card. So the extend relationship will again be in the double angle brackets, extend inside. Okay, take the otherwise scenario. Now if a user says cash, payment by credit card, will this use case will be executed? No, it will never go to payment by credit card because you have chosen payment by cash. So this is on the demand basis as and when required. Let me give you one more example. You go to a bank account. I'm single. I want to open a bank account. Right. This will be done. But if I take my girlfriend, if I take my wife and I say, I want her to be the joint account holder. So there is an extension point which says add joint account holder. So when you two will go and you ask specially for the add joint account holder, then only it will be called, otherwise not. System boundaries, very important. System boundary is a separation. It's a clear distinction between the external and internal parts. So the actors are always the outsiders, external to the system, and internals are the use cases. Because we are discussing use cases. Use cases are the integral part of this boundary. Whatever you have this in the boundary inside, these are the use cases inside that boundary. So you need to specifically show that this is the distinction, this is the boundary, and who else the external people are going to interact. One more thing is there, which is use case description. Whichever use case which you have identified, if you are a student, you are going to go for exam, you don't need this. But if you're going to a company as a software programmer, software lead or program leader, you need to do it. These use case descriptions are mandatory. So I'll just give an example. This is a basic template. Just have a look here. But I'm going to take an example, then I'll make you understand. You want to withdraw money. So the use case will be what? You have to give a number also. Withdraw money. This is the use case. What is the goal? What is the idea? What is the withdraw money that is doing? This use case allow this card holder who is not a customer of the bank or maybe a customer of the bank to withdraw money if his or her daily limits allow it. This is the goal of this use case. Use case is made for this only. What are the preconditions? ATM is well stocked. It should have money and it is in service. These are the preconditions. What are the success end condition? If everything goes good, the cardholder will get money. Failed end condition, if something happens, the user must get an error message that your PIN is wrong or your card is not working. All these, the failed end condition. What are the primary actor? Who is the primary actor? You, as a card holder, you are the primary actor. Who are the secondary actor? All those which are doing the background activities like the ATM bank, like the other card holders bank, they are secondary actors. What are the triggers? Now, whenever you put the card inside the machine, you need to get a money. So the card holder introduces the card in the ATM. That's the trigger. That's the trigger. This is a banking example. We'll make a use case. Before that, let me tell you, an actor must be associated, linked with at least one use cases. At least one use cases. Okay, first thing. The actor can be associated with multiple use cases. Second thing. So I'll take an example. Multiple actors can be associated with single use case. So you are a customer. Let us start with the banking example. You are a customer. If there is no customer, why the bank is standing? So a customer is the basic actor. And if you are a customer, you need to have a bank employee also. You are not just only dealing with putting and leaving money. You are going for loan. There are various activities going on. So whenever you go to the bank, the basic thing is to open an account. Without opening an account, you cannot withdraw money, you cannot put money, you cannot have a loan. So you have open account. So we have to combine the customer with the open account, and the opening account has to be done by the bank employee. So you combine them. Now you want to deposit the funds, deposit the money. Right now you don't require bank employee, because on all these things are automated. So just understand that we are in the present scenario. So what you will do, you will deposit the fund. You don't require bank employee nowadays. So you will link this use case you have made and now link the customer with it. What has been done? Every actor, either a customer or a bank employee, they are associated with at least one use case. This condition is fulfilled. Second condition, the actor can be associated with multiple use actor. So the customer is linked with who? It is linked with the open account also and deposit funds also. Let us go ahead. Now we'll add the generalization. Customer can be a normal customer. Customer can be a loan customer. Customer can be an elderly customer. Customer can be a child or a student. So let me give you an example. A person who comes only for the, say, currency, or he is NRI or NRE account holder. What do we do? So we have an actor here. The work is only NRI or some foreign currency related activity. So we have generalized. The base is a customer, and you can say we have taken a child who is also a customer. So it's a generalization. So the direction should be from the NRFC customer to the main customer. This line should be there. You can say a currency customer, you can name it. You have to name every one of them. What is the use case? As I said, every actor has to be associated with at least single use case. So we'll have a use case called convert currency, and we will link it. So two things we have added. First, we made the actors, and now we have added generalization. Now, I'll also give you a perspective as a programmer. So just assume that this is object-oriented programming, and we have inheritance concept. So if you're programming with Java or C++ or any object-oriented programming language, you will implement using inheritance, because the descendant is inheriting the property of the ancestor. There is a base class, there is a child class. So an inheritance is happening here. You're going to do, while coding or while making classes, you have to do this inheritance when you actually program. Now let us extend. We will add the extend relationship. We have come up till here. What are we going to extend? Now if somebody comes and you say, if you are putting more than $10,000 or you are over 55 years, we are going to give you a bonus. So we will add a extend relationship here. Extend will only come when it is required. Anyone who is below 55 won't get it. Anyone with, say, $9,000 won't get it. So we have a calculate bonus, and this will only happen a ... line from the CB, calculate bonus, to the deposit funds. And we will add extend here, and this is only done when there are certain conditions being fulfilled. Otherwise, means there has to be some trigger. Otherwise, you can write it here also, 10,000 above and age should be greater than 55, like this. So I hope you understand. We added an extend relationship also. So for the programming people, there is extend when we will make a class, an object, So there has to be the function of this CB will only be called when some trigger will be there. So this function is not included. It will only be called when something will happen. Now coming to include relationship. So for the programming people, what is happening here? There is a base class, or you can say base use case. Now whenever this is called, there has to be another function will always be called, and that function is a reuse function. So you have independently made a function, kept it somewhere, and that will always be called by multiple say classes and functions. It is always called whenever certain things will happen. It's not optional. It is mandatory. It's mandatory. So let me give you an example. Let me add it here. Now I hope you understood till now. Now we'll add an include relationship. What does include means? Whenever you deposit funds, whenever you withdraw funds, let me add one more use case here. I'm adding deposit funds and withdraw funds. Withdraw funds. So if you deposit fund or withdraw fund, what will happen? The account amount has to be updated. If you have 100, you just add 20. You have to have 120. If you have 100, you subtract 20. You took out 20. This you have to 80. This is optionless. You have to do it by any way. This deduction and updation has to be done. So this is a mandatory. This is an include relationship. It has to be called every time you deposit fund. So there is no option here. It's mandatory. So you make a line from there, dotted, till UB, and an include in double angle brackets. This is include double angle brackets. So as I said, use case UB will always be called whenever deposit fund is there. There is no if and buts. There is no optionality. I hope you got the idea. So this is the basic idea of the way how you do it. Okay, thank you so much. Take care of yourself.